Okay, tracing your way through Ruby. So the premise of this talk is that 99% of the problems we experience in our work are basically Ruby bog standard errors. So bread and butter is like you get an error message, you look at the stack trace, and then you see where it happened, and then you fix it. This happens in the course of your day while you're on tests. It may happen in production when you're like you didn't really think of a certain case, or user is doing something crazy and you didn't plan or something. So thinking of a number of like very, very standard, totally non-panicky errors. Undefined method for nil-nil class, wrong number of arguments. Anyone can think of other ones that happen like all the time in the course of your day? Network timeouts. Oh. Right. Okay. Anyone else? Sorry? Not convert nil into string. Yep. Can convert string to integer. Sorry? Missing constants. Not to use symbol as index. All right. Yeah. Yep. So those things are things that happen every day. No fear, no problem. But sometimes you get like a segmentation error, or some I/O operation you have like blocks a bit, or your application slows down for no apparent reason, and you can't really explain. So you're like, what should I do now? And my answer to this is, well, tracing the hell out of your Ruby will probably point you to where the problem was. So dtrace. So dtrace is not new, let's be clear. It was written by Solaris kernel developers, so some people, a good while ago, and then it was open sourced. And nowadays it's basically present on nearly any Unix system you can think of, and also BSD systems like your Mac. So basically it's Unix neckbeard territory. So some of you will know dtrace by heart, and if so, then you can read your email or play Tetris or something, because this talk is basically about dtrace. The funny thing is that in like recent talks I've seen about monitoring and logging, there's a lot of talk about publisher-subscriber model being the right one. So it basically distributes, you basically fire events instead of logging in a straight file. You fire events, producers fire events at different places in your system, and then you have consumers consuming those events as they come along. Well, dtrace actually does that out of the box. So it turns out it's not that new an idea. So on one side you have probes, what you call probes. Probes basically have to be dynamically compiled into whatever program you're running at sea level, basically. And why am I talking about this? Well, Aaron Patterson has been working on introducing probes into Ruby. So normally, if everything goes right, in Ruby 2, there will be probes in basically the standard MRI Ruby. And he made like a number of fairly general purpose probes, like for instance, function entry when you enter a function, or when you start garbage collection and you end garbage collection. when you create an object, when the creation of the object ends, when you raise an error, a number of other like probes. To be clear, this is not in a Ruby trunk yet. It's at the moment in one of this repository on a branch called probes. So you can install this onto your system and test it if you feel like playing with it. So this is basically probes.d is where he defines those probes. And it's written in the D language. The D language is basically a scripting language for dtrace. As you see, it's like fairly readable. It's a kind of DSL, really. And you run that through dtrace, and you get like an include file for C, which looks very complicated, as you can see. But you can find your probe again. And they say like dtrace probes have nearly no performance impact. So you can do the same kind of things with GDB scripting, for instance, but that like will slow your Ruby write down because you're compiling Ruby in a way that that it will allow debugging. So it will like throw out of the window a whole lot of optimization of your compilation process. While dtrace, if you compile dtrace in, it's basically adding an assembler instruction saying, right, well, fire an event. And using that instruction also means that the compiler won't go, well, this really does nothing, so I'll just optimize it out. It will keep it there and fire the event. So basically, right, you have an include file. An include file will be used in the C code itself. And so basically, this is in vm.c, so in the VM of Ruby. Aaron added this bit of code himself. And the nice thing there is that, so basically you add that bit of code in your function, and you can use local variables, local accessible variables, like in this case, class name, method name, file name, source line. So if we look back at a probe, it has a number of arguments here, which means you can pass in something to the event you're firing. And he makes sure that when you go through this bit of code in your VM, so when you enter a function, in this case, it will pass class name, method name, file name, and source line to that event. So that's information you can use later. So you don't only have Ruby probes. Ruby probes are the ones that will be present if you compile that particular version of Ruby and run it. But you have a whole metric ton of probes which you can kind of list by doing dtrace-l or sudo dtrace-l on your Mac. Yeah, that's a bit of a wart, I think, on Mac, is that you can only run dtrace as root, so you have to do sudo every time. You can also list only a particular family of dtrace probes. If you're only interested in the Ruby probes, then you can kind of select. So dtrace probes are organized in 4 levels. So we have provider level, which is Ruby. Under that, you have module, function, and name. So you can have 4 different levels of family, basically, of dtrace probes. So that's the producer side. For the consumer side, you can start to get creative because you're using the D language to kind of script which bits of these events are interesting for you, which bits you actually want to see and monitor and use. So let's start with a simple little script. So D language. So I'm interested in Ruby provider events, doing the function entry thing I was talking about earlier on. And I'm going to use printf. So the D language has a number, or the D trace language has a number of subsets of C. So it has printf in this case. And I want to print, well, those arguments that were passed into the event. So basically, to remind you, class name, method name, file name, and then the number of the line. These will be printed in this particular format. And this is a little like side thing you have to add in this situation because you're printing a string. However, dtrace runs as a separate process than your main process. So you're basically working in another address space than your process. So you need to use this little function to like copy in the string that you want to display. And this is what it does. So I run this command line. Simple.d is a script. I want it quiet. I don't want all the information dtrace might add. And then I attach it to a process. And there you see class name, function, or method, sorry, the file, and the line. So you can really see what's running at the moment. In this case, simple Rails request. Well, this was not the only thing that was running. There's like a whole list of functions, really. So I don't know if you're impressed already. So, okay, let's go a step further. We can use thread local variables, which is very interesting. Like you can record, so with self, you can record variables at thread level. So here I'm doing a GC probe. So GC begin. I say, right, I record the timestamp at which my garbage collection starts. And then when the GC end runs, so the other event, then I will print this. So the time basically totally spent in garbage collection at that point. And I print it in a pleasing fashion, a GC time. There we go. And I can add a predicate, so I can add a condition. In this case, it probably won't be much use because GC end probably won't run if GC begin hasn't run before. But just in case, like, if G start is null, then this consumer won't fire. And the result is this. So a list of, so I run this script again, a list of like microseconds for garbage collection. So you can basically see that this can start to be very useful. You can start analyzing things, how things work, how long you spent in a certain function, how long it took to create a certain object, for instance. But it's still, you know, a whole list, a whole 1,000, 2,000 lines of GC time records. You're like, what do I do? Do I import this in Excel? Do I, God knows, you know. So there's solutions for that. So you can start to aggregate in dtrace. So again, function entry events we're talking. So when you enter a Ruby function, so it aggregates here. Aggregate symbol is here. It aggregates over these keys. So in this case, if I remember correctly, class name and function name, and it will count those events. This particular option here will ensure that the sorting is reversed, so that you will see the events, the functions that have been run the most appear first, so the highest counts first. And so we run this. So the aggregate functions are actually only run at the end of your dtrace script. So this is why I have a Control-C here. So I run my dtrace script, I interrupt after having run one Rails request. And I get like a nice little report of what's run the most. In this case, 2S has run 4,883 times. for very minimal Rails app, and inspect for some reason also a whole lot, which is related probably. So you can start to see that is going to be very useful. So I hope you're a little bit more impressed now. But that's not all. There's other aggregate functions, so you can start having actual fun with like these functions, for instance. So there's a number of aggregate functions you can play with, which I'll show in a minute. So it's the same. So it's also with garbage collection time. And this basically just gives you a histogram of all the garbage collection run you've had. So it turns out that most garbage collection times were like 2/10 of a second long, and you've had this many runs, and like the longest ones are basically here. So you can sort of to wonder what was cleaned up there, really. So aggregate functions, you have count, sum, explains itself, average, min, max, standard deviation, and then like kind of distribution kind of functions. So you can see there's a whole lot of options there. You can select on probe, so which probe are you going to analyze? You can add lots of variables. I mean, this is only the beginning. You can start writing whole programs. You can use structs to store all the information you could possibly want and analyze the hell out of it. I guess in the case of the like, oh my God, what's happening situation, the ones where you basically only display what was happening at the time where you crash is probably the most useful. But once you start to dig into it, you can go much further, as you see. There's a number of tools based on dtrace available on Mac mostly. So they're basically sort of wrappers around dtrace, showing you a number of system probes, if you will, but where you don't have to write a script, basically. You can just use them out of the box. So you might have seen dtrace, the equivalent of strace on Linux. So on Linux, I used to use strace quite a lot. dtrace allows you to also see all the system calls that have run, which can be kind of nice because you can recognize, again, where the problem happened, what files have been read in, things like that. IOSnoop is another wrapper function, which will mostly look at I/O events. Like, for instance, in the case of a Rails request, it was quite interesting as well because you saw all the Ruby files being read every time you like do a Rails request, which turns out to be a whole lot. So obviously Rails. And then exec_snoop is more, again, general purpose. It just allows you to see all the programs being run at a particular time. So if you run it in a window and you think something dodgy is going on or whatever, you can maybe trace it with exec_snoop. You can see executables that actually shouldn't run. Though that requires a certain knowledge of your system because obviously a lot of things are going to be run in the background which you're not aware of to start with. So I saw like a lot of people, like smarter people than me, were using instruments on Mac again. Sorry if this is a bit of a Mac-centric talk. So Mac has instruments, which is broadly, it is a GUI on top of dtrace. So you can do, if you're more into pointy clicky stuff, you can use instruments instead of using command line. And Well, there's a number of like standard options for instruments where you just pick a template that's there, you attach to your process. And so I go for screen and I run that Rails request again, which is a bit the use case at the moment. And it returns like a whole number of system functions that were run and how much time was spent in them, because I used the time profiler function. You can also have your own dtrace custom script. Like you recognize this is GC time again. So GC begin, GC end. I write a script. I attach it to the Ruby process as before. I record. I go off and run the Rails request. And I have a little graph with like call stacks and the times, the GC times for a certain call. I'd really like to speak to people who use instruments as part of the course, because I've seen people doing very, very advanced stuff with it. So far, I've used more command line, but if you can have nice graphing possibilities, for instance, it could be interesting to work with instruments. Instruments is also used quite a lot in iPhone dev, so people who do iPhone dev probably know instruments quite well. So, okay, what about JRuby? So JRuby people will be feeling a bit left out by now. It's all very C-ish. But let's remember that the JVM basically also has C and assembler parts. And so if you're really hardcore, if you're really low level, you can actually trace what your JVM is doing, because the JVM has a number of probes inbuilt as well. So if you want to see JC begin or when the thread starts, you can do that no problem. So I encourage you to read about it if you're interested. So it can be interesting as well. Though there's fantastic GUIs to see what the JVM is doing. So I would actually really more go there. But here we go. So dtrace is great. Dtrace allows you to see a whole lot of what is going on. It allows you to analyze the hell out of your program, out of the low-level things, out of the more high-level things. It's great. Yet, sometimes it's not enough. Like, for instance, like about a few weeks ago, I had illegal hardware instruction appear on my Mac. I was happy it wasn't in production, because illegal hardware instruction, what can you do? Even if I trace where it is, I have no idea what to do with it. I don't do assembler. I don't know what the VM is doing. So, yeah, there are still possible scenarios where dtrace will not help you. In my case, upgrading Ruby solved the problem, fortunately. So, there we go. Thanks for your attention.
Hi.
Hi.
Sorry. Thanks for the speech. Very, very interesting. I was wondering, what kind of tool support is there right now for like doing this in Ruby land and just having a nice wrapper around D? Because I'm not really comfortable writing everything in D and trying to communicate that with team members.
Yeah.
Is there like a clever way of just saying I want these things and just?
Well, actually, folks have written Ruby dtrace. I've not used it myself, but if you Google it, there probably will be instructions on how to install it. So even for older versions of Ruby, you can do that. Although, to be honest, I don't think it's that hard to write it yourself. But yeah, maybe it's a bit too much to ask. We do Ruby after all. So.
I guess a lot of the time it's the same things you're interested in, right? Number of method calls and duration and stuff that you just like work out of the box.
Yeah, that's true. I guess with memprof and stuff, you can already have a certain level of statistics there.
So, thanks.
There you go.
Thanks. One question. When you summarize, the only way to get the output is shooting down, stopping or quitting the trace. It's not possible to get periodic updates because you said in the example that you have to quick the trace in order to get all the summarization, say the counters or whatever. There is no way to periodically update that?
There's examples. I'm thinking of, if you Google BSD dtrace examples, there's like ways to have like a second tick and then it counts per second. So that's very possible.
Hi. That was really useful, thank you. I'm wondering, when you set the local variable with the garbage collector, when you set it to start and then later on when it finished and did the time between the two, is there any support for setting sort of arrays of variables or things in there? Because obviously every time that same method gets entered, it's going to override the original value. I'm thinking functions being entered, that sort of stuff, so you can report on that.
I would imagine so. I don't really think I understand. The problem you're thinking of is when...
Shall I explain?
Yeah, please.
So you entered GC start and it set a time, and then you enter GC end and it sort of outputs. That's fine when you've got a pair in that effect, start and end, because every time you hit start, presuming end's going to have finished. But if you did the same sort of thing on, say, entering a function, then obviously you might enter lots of functions, but you might want to see how long a function ran. Yes, well, yeah, I think you can use those variables to basically filter out. I can imagine you can, instead of keeping one variable, keeping a sort of hash. Also, you have to remember that it's thread local, so it will only run in. It's locally to your thread. So I think using yeah. Some sort of hash would work.
Yeah, I think that there's also examples online. I can't really think of
you.
how they do it, but yeah.
Thank you, Elise.
Thank you.
A big applause for her.